Continuing with our topic of loss of GM, virtual loss of GM in dry dock and grounding conditions. So today we do one problem on grounding. It's an examination type question, and we apply the same knowledge of finding the loss in the GM as we did in dry docking. So it says that ship of length 140 meters, center of rotation 2 meters, forward amidships, km 6.1, kg 5.5, MCTC 130, TPC 16, displacement W in floating condition 5700. So she was at draft of 4.15 and 4.85 meter and lightly grounds on a rock which is 10 meters above her stem. The tide then falls by 80 centimeters, 0.80 meter. What will be her virtual GM after the fall of tide, and final draft forward and aft at the end of the drop in water level. So if you see here this diagram, we use the knowledge that the point at which the ship is grounded, which is marked R here. You can see this R on the keel plate. This is a position point on the ship's keel plate R, where she has struck the rock. She is grounded at this point on the rock. So after the grounding, whatever will be the fall in water level, the draft at this point R, which is at grounding, will also reduce by the same amount as the water level. So how do we tackle this problem? Of course, there is an upthrust force P acting upwards at this point R, and it is equivalent to we have discharged P tons of weight from this point R at the keel. So when you discharge weight, there are two phenomena take place in the change of draft. One will be the mean rise, parallel rise, and the second will be the change in the draft due to trimming effect. So we consider like P tons of weight has been discharged from this position R. So what will be the change in the draft at this position? So let's see. So fall in tide what will be equal to the change or reduction in draft at this location R where ship is grounded. So that change in the draft will be comprising of mean rise plus change in trim at point R. Okay. So same principle we are applying as if P tons of weight has been discharged from this location R where the ship is grounded. So when the weight is discharged, first of all there will be a mean rise, then there will be a change in the draft due to trim, and that will be equal to the fall in tide. So mean rise, fall in tide given in the question is 80 centimeters. Okay, tide falls by 0.80 meter. Mean rise is always weight discharge P tons upon TPC. What will be this change in the draft at location R? Rather reduction. In this case, reduction because the ship is grounded forward of center of flotation. So upthrust force P is acting forward of center of flotation. So there will be a reduction in the draft forward. And also at this location R where she is grounded. So reduction due to trim will be change in the trim upon LBP. All the changes in draft take place in the same ratio. So the ratio is total change of trim, which is here T upon LBP, length between total length, which is LBP. So this ratio, in the same ratio, the drafts will change. So total change in the trim is over a length of LBP. So change of trim upon LBP into distance of this position location R from center of flotation is RF. This is the point to understand that, like when you do the change of draft after, when you do change of draft after, you say we do change in the trim upon LBP into LCF. LCF is nothing but distance of perpendicular from center of flotation. Here we are finding change in draft at location R. So the change is in green. I just marked here the green line, which is the reduction due to trim here. So this and we compare it with the total trim. So total trim upon LBP. This is a ratio, and here the ratio is the change in the draft at R upon distance from center of flotation. It is in the same ratio. So it will be change in trim upon LBP, just multiply by distance of the grounding location from center of flotation here, which is RF in this case. Okay, we are trying to find P upon TPC given in the question is 16 plus. Now change in trim. What is change in trim? Trimming moment upon MCTC. And what is trimming moment? Trimming moment is force multiplied by the distance from center of flotation. What is the force? Force is P. Upthrust force is P. What is the distance from center of flotation? RF. Okay. This is the P into RF is the trimming moment. P is the force multiplied by distance from center of flotation, which is RF. So P into RF and upon MCTC. This is the change in trim formula. Force multiplied by distance from center of flotation, which is trimming moment upon MCTC. So change in trim TC is this. Now remaining is again RF upon LBP. This is RF upon LBP remains, and change in trim formula we have inserted P into RF upon MCTC. P upon 16 plus P. Now RF, the grounding is 10 meters aft of the forward perpendicular. So this is 10 meters. I marked here 10 meters. And you can see the center of flotation is 2 meters forward of midship. And midship half length is 70 meters because total length is 140. So half is 70 meters from midship to forward perpendicular. So center of flotation is 2 meters. Then this is 10 meters. The location of R from forward, remaining is 58 meters. You can also do by, you can multiply, you can subtract AR minus AF. A is the half perpendicular. AR total is 140 and R is 10 meters from forward. So AR will be 130 and minus LCF. LCF is 72 in this case, is 2 meters forward. So 130 minus 72, again it will be the same, 58 meter will be the distance between center of flotation and the grounding position R. So that is 58 meter RF. 58 into 58. MCTC is 130. And length between perpendicular 140. So mean rise and the change in the draft at position R due to trim effect, we add them. This will be the total reduction at point R, and that is going to be equal to the fall in tide because it is grounded at this location. Whatever will the fall in tide, that will be the change in the draft. 80. Okay, so you can solve this now. For the force of B, there is only one variable in this equation, and if you solve for P with your calculator, you can get something around 323.45 tons. This is the upthrust force P after the tide has fallen by 80 centimeter. The upthrust force P increases to 323 tons, and this is the effect of it on the draft is like 323.45 ton has been discharged from this location where the ship is grounded. This is the effect on the final drafts and the GM. So we have got now P. What is the virtual loss in GM? The formula, there are two formulas, we can use any of them. So P into, we can use this formula, P into Km upon displacement, original displacement. We have found P 323.45 and Km is given in the question 6.1. Divide by displacement, original displacement 5,700. This virtual loss comes out to be 0.346 meter. So Km is given as 6.1. Kg given in the question is 5.5. There is no FSM given, so no free surface. So just the GM solid will be 0.6. And what is the virtual loss? We calculated 0.346. So we subtract this virtual loss 0.346 0.346, and we will get the virtual GM at that point after the tide has fallen by 80 centimeter, 0.254. So far you should have understood that what we are saying, that the fall in tide at point R, what will be the effect at the draft, on the draft at point R, which is the point where the ship is grounded. So whatever is the fall in the tide after grounding, that at the grounded location where the ship is touching the ground, at that location the change in the draft will be equal to the fall in tide. And using our knowledge that upthrust flow is equivalent to P tons discharge from this location R. So when you discharge P tons from location R, there will be a mean rise because you are discharging P upon TPC plus trim aft. Due to trim, the change at location R will be total change of trim upon LBP, that is the main ratio, into distance of the grounding location from center of flotation. So RF is the distance of distance from center of flotation where the ship is grounded. So we just fill in here the values and we got the answer of force P, 323.45 ton. We use it in the formula for virtual loss, P into Km upon W, and virtual loss is 0.346 meters. Km minus kg is GM solid. Then subtract this virtual loss due to the upthrust force P. This is loss, and you get the virtual GM at that point will be 0.254. Now they are asking that after the tide has fallen by 80 centimeter, what will be the forward and aft draft? So what will be the forward and aft draft? First of all, let's find the mean rise. Mean rise is P upon TPC, which is 323.454 upon 16. This will be in centimeters. So if I divide by 100, I will get in meters. 0.202 meters. What is the total change in trim? TC, total change in trim, is given by trimming moment, which is P force P multiplied by distance from center of flotation 58 upon MCTC. So it should insert the value of P, 323.454 into 58 upon 130 is the MCTC. This is a total change in trim, and we get this answer also will be in centimeters. So you can convert that later in meters also by dividing by 100. So if I divide by 100, it will be in meters. So 1.4 1.43 meters. So I divided the formula for change of trimming moment upon MCTC gives the answer in centimeters. I divide by 100. So you get change in the trim 1.443. What will be the change in the draft? Now trim due to trim. Now we got the mean right. Now we find the change in draft aft due to trim. So that is total change in the trim multiplied by, because it's from aft perpendicular now, we're finding a change in draft at the aft perpendicular. So we multiply by LCF, which is the distance of aft perpendicular to center of flotation, upon LVP always. Because total change in trim upon LVP, this is the main ratio. And wherever we are finding the change in draft, we just multiply by the distance of center of rotation from that point. So in this case, it is aft draft, so LCF. It will be 1.443 into LCF is 72, because it's 2 meters forward of midship, upon LBP 140. So in meters 0.742. This is the change in the draft aft due to trim. And what will be the change in draft forward? You can do total, you can subtract this from total change in the trim, or you can also do the change in the trim into forward length, means length of the forward perpendicular from center of rotation. So that will be 68, because center of rotation is 72 meters from aft. So forward perpendicular will be 68 meters from the center of rotation. So you can also do by 1 upon 140. So again 1.443 into 68 upon 140, and this comes to be 0.701. So if you do this 1.443 total change in minus 0.742, you get the same. This is just to show you that there are two ways. You can always do like this also, just for the knowledge that forward change in the forward draft can also be found like this. So now we will apply this to the individual drafts. We write forward aft. Drafts were 4.15 and 4.85. So first of all, we had mean rise. Means you have to subtract everywhere 0.202, 0.202, and we get 3.948. And here's 4.85. 6 for it. And now we apply TA and TF. So the upthrust is in the forward of center of flotation. So of course the forward draft will reduce and aft draft will increase due to trimming effect. So minus 0.701, which we have already worked out, and plus 0.742. So it comes to 3.247 meters and aft draft 5.39. Okay. So this is how you approach this kind of question. It's actually a sample question in the past papers. So remember this, the location on the ship, the point of on the ship which is grounded, which has touched the ground. At that location, after the grounding, whatever will be the fall in water level outside due to tide or something, the draft at that location where the ship is touching ground will reduce equal to the fall in tide, fall in the water level. So that is 80 centimeter fall in the tide. And we know that our knowledge that the force P, which is upthrust force from the ground acting upwards, it gives the same effect as if a weight equal to P tons has been discharged from that location. So when you discharge weight, it's mean rise plus change due to trim. Mean rise is P upon TPC and change due to trim at location R will be in the same ratio as the total trim. So total change in the trim upon LBP, this is the ratio, main ratio. We just then multiply this with the distance from center of flotation of that point where we are finding the change. Here we are finding point R. So RF is the distance from center of rotation. This will give you the force P, and force P, after the force P you get virtual loss in GM by applying any formula you want, P into Km upon W or P into Kg upon W minus P. Both are acceptable. This will give you the virtual loss in GM. Find the GM by Km minus Kg and subtract the virtual loss. You will get the virtual GM at that time. Okay. And then we find the mean rise P upon TPC, and we find the trim aft and trim forward TA and TF by applying the formula. Total change in the trim will be trimming moment upon MCTC. TA will be total change in trim into LCF upon LBP. TF will be, you find a total change in trim minus TA. That will be TF, but you can also do that by total change in trim upon LBP into distance of forward perpendicular from center of flotation, which is 68. You will get the same answer. And then as we do in the trim questions, apply these corrections which we found just now, mean rise and TATF, to the individual drafts. Individual drafts provided were 4.15 and 4.85. We applied mean rise and TA and TF to get the final forward and aft drafts after the tide has fallen 80 centimeters. Okay. Thank you very much. And if you want to leave your comments, you can leave your comments, and any questions and doubts can be left in the comments. I will be happy to answer them. Thank you.